Hello, everyone. Welcome to the virtual Distinguished Lecture Series presented by the IEEE Instrumentation and Measurement Society. My name is Judy Sharman, and I am the Operations Manager for the Society. On behalf of Salvo Baglio, President of the Society, and Kristen Donnell, Chair of the Distinguished Lecture Program, I welcome you. And now it gives me great pleasure to introduce our speaker. Dr. Octavian Postolaki is an assistant professor with Rehabilitation, ISCTE Institute, University of Lisbon in Portugal. He is also the director of the ITIUL branch at the Institute of Telecommunications in Lisbon. Dr. Postolaki is author and co-author of 10 patents, 4 books, 14 book chapters, 55 papers in international journals with peer review, and more than 190 papers in proceedings of international conferences. He is very active in the IEEE and the IMS. He is an IEEE senior member with the I&M Society. He's technical advisor of the IEEE EMBS Portugal chapter, and he's also a member of that chapter. And now it's my pleasure to present Dr. Octavian Postolaki with his talk, Smart Sensors and Tailored Environments for Neuro-Motor Rehabilitation Monitoring in IoT Era. Octavian.
Thank you, Judy. I'll share now. Hello, good morning, good afternoon, good night, everybody. It's a very big pleasure to give this webinar, and in the form of Instrumentation Measurement Society, that I want to thank that they organize this kind of events, considering this situation that we cannot meet face to face, but look, the technology help us to meet virtually. The topic of my presentation sounds sensor and tailored environments for neuromotor rehabilitation monitoring represent research work in the last 15 years when we developed together our team in Institute of Telecommunication and also in Institute University of Lisbon, research in the field of sensing, virtual and mixed reality for rehabilitation, smart equipments, and taking into account these achievements, I would like to present some of the implementation. Actually, the outline of my presentation, it's represent the facts, technology, and challenge, the motivation of this work. I will speak a little bit about the IoT technology and the possibility to use the IoT in the field of healthcare, particularly in the field of physical rehabilitation monitoring. And here I will speak about instrumented walking aids, wearable sensing solutions, serious game for physical therapy, and at the end I will give some words related to the usage of thermography for objective evaluation of physical therapy outcome and conclusions. Few words about the Distinguished Lecturer Program. Actually, Judy spoke all of this about this, but I want to thank very much to Christine O'Donnell, that is Distinguished Lecturer Program Chair, that actually worked hard to make program successful. And nowadays we have many talks around the world, this year virtually, but in the past year, face-to-face meeting, very interesting for all the IEEE members. Thinking about physical rehabilitation, we consider 2 groups of people that need this kind of services. We speak about the stroke patients, that actually there are about 15 million people that suffer stroke worldwide each year, according to World Health Organization. And about 5 million of these people required motor rehabilitation and even cognitive rehabilitation services. Usually these people are over 60, but nowadays, taking into account the stress that we have in our societies, the age that people that suffered stroke events, it's lower, sometimes 35, 40 years old. At the same time, we consider another group of people that actually they are young people mainly that suffer cerebral palsy. There are about 17 million people worldwide suffering this disease, and they require important physical rehabilitation in the first years of their age, of their life. And we have about 201,000 Europeans that suffer this motor disorder. And for this kind of people, we need even more imagination and good solution, thinking about the difficulty of acceptance of our solution. Thinking about the actual today solution in regular clinics, we can mention mechanical device, very classical device that cannot give us any feedback and cannot give to the physiotherapist any feedback, taking into account that they are really mechanical. And the only thing that physiotherapists can make is to appoint and to make visual evaluation of the situation during the physical therapy process. Some objective evaluation exists, but also again, in regular clinics with mechanical devices. And in some cases, we can talk about subjective evaluation. And here I can present here a pain scale that the person can express the pain according to the exercise that he is running. This is very subjective and depend a lot of sensitivity of each person during the rehabilitation process. One of the idea is to continue to use the same equipment, but we include sensors that can communicate and deliver data. Very important to have an idea about the physical therapy outcome for each person, and if the plan that was imposed by the physiotherapist is the right plan for the right person. Here we can deploy sensor on the equipment, but also on the level of the user, providing information like kinematic and dynamic parameters. We can inform about the EMG signals, about force, applied force, about acceleration, direction, and all. Actually, we have about 1 trillion healthcare devices that are connected nowadays, but also the number of devices that are active in the area of physiotherapy, they are quite reduced. This is a challenging problem because the implementation of IoT in physical rehabilitation can improve the quality of service also in this field of healthcare. Thinking about the technologies that we are working in IoT, I mentioned here some of the technology that can bring value to IoT. And here we speak about the short-range communication protocol like Bluetooth, Bluetooth Low Energy, Zigbee, Wi-Fi, but also 3G, 4G, and nowadays 5G. RFID, near-field communication are also important for the implementation of IoT systems. We still are using barcode and QR code, sometimes for identification of the users. The sensor and smart sensor on the level of different of equipments and also in wearable solution. The mobile device, thinking about smartphone and the tablet that are commonly used to visualize the data and even to to share the information or also to fill the information about some user. And we can speak here also about the edge, fog, and cloud computing. That is very important when we think about data processing. Nowadays, the edge and fog become very important too, thinking about the capability of the processing to be implemented on the level of the device. However, we still continue with the cloud computing like an important platform to make data, to implement data analytics and big data in order to extract information, the useful information for the physiotherapist and not only. Some elements about long-range communication. Here it's some of the important. I mentioned here LoRa, that it's actually deployed in many, even in our university, we have LoRa implementation and provide possibility to deliver data for long distance, like 11 kilometers, up to 11 kilometers. There are also another solutions. In some countries are implementing, other not. We speak about narrowband IoT, that it's still under implementation in several countries in Europe. But also some important part is the communication protocol. Thinking about communication protocols, I want to mention here different protocols that are used to allow device to expose their feature and communicate with external and centralized service like cloud and database. And here I can mention one of them that become very important in IoT is MQTT, and with some architecture that imply MQTT broker, publishing of the data from the sensor and subscriber from the level of different smart device or client and computer. We have also a general architecture that we can consider, thinking about the wearable healthcare solution. Here, some of the sensors are deployed on the level of the body. One of the central nodes receive the data from different sensors. That can be also some data from accelerometer or even from cardiac assessment sensor or respiration sensor. The data is delivered through the central node. For long range, we can use different type of communication, including 4G, why not for 5G in the future. And the data is going to the cloud side, where machine learning can be implemented in order to extract information, useful information about the data that come from the sensor. This information can be shared with general practitioners, specialized people, nurse, carrier, and they can take the right action, the right plan in order to improve the quality of service in physiotherapy. Thinking about these important achievements in IoT technology, we start to develop one of the first architecture that was expressed by a set of equipment that help people during the rehabilitation in order to preserve the balance and to train the gait. Here I mention several type of walkers, standard and walker with two-wheel walker, four-wheel walker, and also crutch. Different kind of communication, short-range communication, Bluetooth or Zigbee or Wi-Fi, were used to deliver the data from this smart equipment to the computation platform, client computation platform that deliver the information to the cloud, where the data is processing, and the information of the processed data can be obtained by physiotherapist, physician, or accompanying person. Also, here we have, in particular, one of the implementation where a standard walker deliver the data to a to a tablet that actually was used as a gateway. The communication was done using Bluetooth, The tablet will deliver the data through Wi-Fi internet to a remote server where the database was implemented using MySQL. And using some PHP scripts, the data is processing and later can be visualized using some mobile or web application. Related hardware, we can speak here about hardware and the elements of IoT ecosystem. We can speak here of several layers: a sensor layer, edge layer, where we perform the primary processing, communication layer, thinking about Wi-Fi communication or Bluetooth communication. That means we can deliver the data directly to the cloud, or we can make intermediary processing and, let's say, the storage in the local database on the level of the tablet. And at the end, the data is delivered to the cloud where specific processing is carried out. And the results of the analyze and processing can be presented in a website using responsive technology. That means we can even visualize again in the tablet or smartphone. Several elements of the system I can mention here: the identification based on RFID technology, usage of IMU expressed by 3D accelerometer, 3D gyroscope, and 3D magnetometer in order to extract information about direction, about acceleration, velocity. Also, elements of the distance between the worker and the floor we are using some ultrasound ranging system, and also the force applied on each of the leg was obtained using a load cells. The prototype was done. We make several tests, including in some small clinical facilities, physiotherapy clinics, and thinking about the software was developed a mobile application for Android OS devices, but also a web application where we can actually impose the training plan. We can visualize different kind of data. Even we can visualize the distribution of center of pressure during the training session. Several tests were done also in laboratory, thinking about 5 meter straight walk and also 5 meter zigzag walk. The distribution for people that suffer some impairments or volunteer without impairments, we can see here the distribution on different parts of in the one corner or another, according to the impairments, the leg impairments or the side impairments, thinking about the stroke patients, and also the distribution for the volunteer without impairments for 2 of the routes imposed. But thinking about objective evaluation, we discussed with the physiotherapist, and they consider important to define and implement some indexes that can give some information about the walker usage. And was defined the imbalance index, thinking about balance of the user during the walker usage, but also elements about incoordination. This is more or less related to the fact that the right usage of the walker go to good results. The incorrect usage of the worker can go to the accidents. That means we need to develop and to implement an index that give incoordination index where we can define the right usage. And here we consider a finite state machine where we have different state that was defined together with physiotherapist. The state 0 waiting for walker to lift, step 1 walker is flying, and so on. And we can, if all these states are followed correctly by the user, we have, let's say, the index of the imbalance of the index of incorrect usage of the walker will decrease. If the user don't use correctly, we'll have high values of this index I2. And based on this, we can give advice or can provide additional information to the user in order to correctly use the walker, and in this case, to avoid accidents on the walker usage. Actually was implemented some software to visualize both of the indexes, and also we can see here during the training, we can see the center of force that would move from one part to other. We have also expressed it here, all of 4 legs of the standard walker, and we can see also the evolution of index of the balance during the different states of the walker usage. Another implementation, this time I will mention only the fact that together force that was mounted in the hand support, flexi force sensor that also can give us information about balance, also was implemented microwave radar sensor in order to extract the pattern of walking during the training session. And based on short-time Fourier transform, we can extract important feature that can later be evaluated in order to extract information about the correct gait, and if the person need to continue to use the walker, or it can start training with crutch or even without any support. Some implementation was done in using Android. We also consider the possibility to add, to develop, let's say, a software module that permit us to add new sensors, sometimes commercially, not developed in the lab. We speak here about pulse oximetry that can give us the oxygen saturation, heart rate during the training session. Another important development is related the smart crutch. Actually, after using the walker, the people are moving, let's say, smoothly to the usage of other kind of devices, of equipments, thinking about crutch. And here actually was implemented a system that can measure force, acceleration, direction. For this reason, we are using 2 kinds of force sensors, one of the load cell, other flexible sensor on the hand support, and also was implemented an accelerometer and the 3D gyroscope and 3D magnetometer. The data is delivered from Arduino Nano platform to a smart device that can be tablet or smartphone. And this device will process the data primarily, will store in a local database, and when internet is available, will deliver the data to a remote database where the PHP script was implemented, giving us the possibility to receive also processed data. Here, this is one of the prototype. Actually, we can visualize here the hands applied force, the flow reaction force, and even roll and pitch angles associated with gyroscope. I'll try here shortly to show some test that was carried out. Actually, based on the application that was implemented in Android OS, you can see during the test that we can visualize different values provided by the sensors, especially accelerometer, gyroscope, and also the force applied during the gait. Why these values? Because sometimes the people are using crutch, thinking that are still unstable, and think about their safety. It's very important to know if exactly the force is applied, or the people are thinking that they don't have enough balance to go without crutch. Another thinking about people that already recover and can continue training without crutch was walker. We developed several solution, let's say wearable solution, that imply some force sensor mounted in insole, and here we speak about smart insole, and also some IMU that also give additional information for the gait, thinking about the gait classification and developing a model that can later be used to improve the applied training plan and to see which are the problems that some kind of this of patient under rehabilitation can still have. Another implementation, this time that we speak about smart insole, but using the fiber break ratings with a project we are working in, where actually the FlexiForce, that piezoresistive sensor, were replaced by fiber break rating sensor array. We can see here different measuring points. Actually, we have two array of the grating sensors, the fiber breaking rating sensors, where you can measure in different points the applied force and the distribution of the force during the gait. I will now go in details thinking about the shorter time, but what I want to say, the general architecture include also not only the array, but also is very important. IMON interrogator that it's very small, and this IMON was connected to a computation platform where we implement some LabVIEW software, and here we can see actually different line of the spectral of the reflected spectrum from the gratings that correspond to the measuring points of the force measuring points. The idea is to continue wearable, but also to develop something that can motivate and can give some help home when the people are training home. And the idea was to develop something that we mentioned, like wearable mixed reality rehab project, where actually we are using mobile platform expressed by iPhone that together with IR kit, augmented reality kit, in order to implement, let's say, virtual personal trainer or virtual personal physiotherapist that can give to the user information about the rehabilitation plan for each day. Normally, the person that are not going every day to the physical therapy clinics, and in this case, we can see that it's very necessary to keep training home. And we develop actually some, first of all, the physiotherapist can impose the training plan that is personalized for each user. You can see here, let's say, a collection or a dictionary of different motion. And after this will be delivered through the internet connectivity to the user that can practice his exercise according to the indication provided by, let's say, virtual personal physiotherapist. According to this, the user can follow his training plan. I can mention here some sensor that was actually part of wireless body area network. We speak about ECG, AMG during and also the acceleration sensor that can give us information about the training session in objective way. Moving forward to this mixed reality or augmented reality implementation for physical rehabilitation. We mentioned here another system that actually put together 3D scanner expressed by occipital structure sensor. We can see here the sensor that was used together iPhone platform that together are using as part of a headset, but also some sensor that give us information about the stress and also the heart through the heart rate and skin conductivity. All of this information, it's are very important to extract the status, the health status during the training, but also to extract objective values related the training, the imposed training. Also here, we impose in order to extract additional information about gait, a smart carpet provided by Future Shape, okay, that provide us information that they are capacitive sensor distributed in matrix that give us information about the gait. And all these are used in order to perform during a serious game. Was developed 2 serious games. One is the maze, that actually we have a maze with different objectives to catch some important object. And in this case, we can evaluate the balance during the game practicing. The motivation is higher than when we are using, let's say, a personal or a virtual personal trainer. And because make people more autonomous, and also they are motivated by the game objective. Also was implemented a treasure serious game that also it's more related balance, and we can see that actually person can move from one to other using different let's say points that must be reached in order to reach the treasure. After game practicing, some metrics are evaluated. Thinking about trajectory, we extract some error of trajectory that is more related to the capability to and the balance of the users. And also we can extract different information about velocity and direction of the motion. Thinking about augmented reality, also we develop and virtual environments. We also think about virtual environments, not only virtual object, but yes, virtual environments. And we speak here about semi-immersion, taking into account that the people prefer semi-immersion to work with virtual reality. And we developed some games that are using Unity 3D to develop some environments, virtual environments, and the interaction with these environments was done using a set of smart gloves. Here, I mentioned a set of technology. Actually, the smart gloves primary processing is based on Arduino Nano. We have different kind of sensor. Here I can mention FlexiForce to make the force, the flexion of the finger, and also accelerometer that is very important. And we implement here some specific fusion algorithm in order to extract information that can give the possibility to navigate in virtual reality environment. That means the information from the smart gloves and the headband that give us that headband. It's used to to concentrate the camera in the direction of the motion in the virtual environment. And we develop actually 2 games. hands down game and coffee pong game using technology, software technology like Unity 3D, C#, and Visual Studio. Also, in order to provide information, the data from the client server, where the game, the client side where the game is running, it's updated in the remote server. And after this, the database is used in order to provide information by a mobile application that was developed using Xamarin cross-platform. Here we have some, let's say, some image of the application. First of all, one with QR code that is used to identify the user and to start the game. And after performing the game, we can see the analyze screen where we can visualize different values of, in this case, of gyroscope, pitch and roll angles, but also you can analyze the data offline, and we can see here the variation of different right hand fingers pressure during the game or right finger extension during the game practicing. We are moving, thinking about virtual reality. This more or less it's nowadays a classic approach based on Kinect. Exists one Kinect V1, Kinect V2, and now it appear a specific, let's say, Azure interaction natural user interface that we are planning to use too. And we develop actually for physical rehabilitation, for remote physical rehabilitation, maybe in this period is very important. We develop an architecture where we include the Kinect sensor on the client side that practice the game on the client side, the patient together physiotherapist in clinics, but later the patient home. That means this device actually provide possibility to make complementary physical therapy. That means the physical therapist, we can use the classical method, but also this system. After processing on the server side, the therapist can receive data that was obtained during the training session in clinics or home. Few elements about the Kinect. Actually, it uses higher spectral pattern in order to, and for sure, artificial intelligence algorithm. And at the end, in the case of Kinect V1, we obtain the XYZ position of different joints, about 20 joints, and the Kinect V2, 24 joints. And this camera is very important that give us not only XY, but also Z. That means we have a depth sensor. Few words about serious game. Actually, we mentioned till here many of this implementation, but actually what is very important that refers to the use of computer game without the main purpose of providing for entertainment. That means help people to be more motivated during the training session based on virtual reality. Several games was developed, Terra Soup, Apple Harvesting on just Physio Kidding. We have even more, but here I mentioned this. The first game that we developed was in this form. Actually, we test this game in different clinics. What is very important that through a web page, the physiotherapist can impose different limitation for the game. That means the angle that we can do and the time duration, the score objective and so on, in order to even motivate the user. At the end of the game, we can see a graph of velocity, of angles that the person make. And also it's very important that we include also a scale of pain, but this time it's subjective. Actually, we are asking the people to give a score between 0 to 10 about the pain that he suffered during the training game and the training session based on virtual reality game. And moving the hand, it's possible to give an information about this pain. Also, some physiotherapists say that, okay, virtual is good, but also it needs some force, balance, and so on in order to avoid accidents. And there was included in the system a force platform with 4 load cells. And this force platform include primary processing in a platform on the level using a low consumption microcontroller from Texas Instruments, but also a Bluetooth communication that deliver the data directly to the virtual reality serious game. The data from the force balance, the force platform, it's also delivered together, the data obtained from the game. And we can even see during the game with some, it's very important, the relation between the score, the motion of the person, and we can see the trajectory of center of pressure during the left arm training, right arm training, or even we can see some amplitude, anteroposterior and mediolateral amplitude during different phase of the game. The idea was to develop environments that are very attached to the user, and in this case, we developed some additional games. This is apple harvesting. As we say, it's very personalized for men, women, and also we can see that also according to the needs of the user, we can impose a scenario with low angles. We include also different environments, sounds that can motivate the people, or very higher difficulty game where actually the user need to train for higher angle. And also it's very important that the person can feel motivated and the game can have better acceptance. Related the cerebral palsy, you can see here different games that are more appropriate for the young generation or young people that suffer cerebral palsy. Here we mentioned actually in this case, all the game was developed in C++, and we make tests actually with real patient and we still continue this test with real patient in the physical therapy clinics. After gaming, we have also the results on even the recovering of all the motion that the young patient are making during the physical therapy session. Also, exists a big flexibility to include different type of motion in the game. And now we are trying to move from the big amplitude motion of the hand to monitor, let's say, very teeny motion of the finger. Thinking about this, the Kinect is not the right solution. Actually, we cannot sense different position of the finger. And in this case, the idea was to use the lip motion, and the lip physio system include the lip motion controller that actually detect the position of the finger with a high accuracy. This is connected to the client side, executing the game. The client will synchronize with the remote server, and the remote server where we have a MySQL database and the PHP script was process the data and deliver the information to the tablet computer, a tablet where the physiotherapist can visualize the data, or also the report generation was carried out. And again, we generate a care card for the user, Actually, they can start the game using this QR code that is presented to the computer camera. And at the end, we can see here some few elements about the sensor, the lip motion controller. It used, comparing with the previous one, Kinect, it used 3D stereoscopic image technology, including 2 camera, track infrared light produced by 3 infrared LEDs. And at the end, we can see here so many position of the joints of the finger, yeah? And we can see the user can focus in training one or other part of the, let's say, a finger of the hand, or according to the training plan. Some games was developed. One, a simple game. This kind of game are also designed for cerebral people person, and we can see here personalization with the robot arm. Sometimes for the kids, we can also training both hands, only one, according to the needs. And also thinking about cognitive rehabilitation was implemented some group of, based on theme, objects that sports, animals, and fruits can be recognized and put on the right box. It appear and you need to catch them and to put in that. We have important elements about score, but also we have at the end information about the data that is provided by the sensor for different joints of the fingers. And at the end can be obtained information about the capability in time, the developed capability in time of the person practicing this kind of serious game. For this reason, we have the data on the database. Here we can choose only one coordinate or only one joint. The simple way was this one here to present, to be more easily to express, but also we see here point-carrier plot or Z position of right and left hand for user. That means you can compare the different, the capability of different users that are practicing this kind of training. Some mobile application in Android was developed in order not only to visualize, to identify the user, visualize the score, but also visualize the position of different, we can choose which joint is important to be visualized with bond and so on. And velocity also can be visualized, taking into account that all this information was previously stored in the database. And the last part of my presentation comes because the physiotherapists are always thinking, how about real training with virtual training? Is real virtual training enough powerful to improve the capability of the person? And it's quite difficult to estimate how it's running this kind of training. And one idea is to use an obtrusive evaluation of muscle activity. And for this reason, the thermography is one of the solutions that actually it's part of remote sensing. Few words, we know very well that every object whose surface is above zero radiate energy at the wavelengths we have, wavelength we have here 3 to 5 micrometer and 7 to 9. And we can obtain thermographic image. Nowadays in clinics where I'm working with a very interesting group in Porto that actually make many tests in clinics only to visualize, let's say, different problems that appear even from breast screening or other kind of things, chronic acute pain, that give us information. However, in our case, about, let's say, the needs of rehabilitation, or during the rehabilitation, we can have a feedback if the rehabilitation is running well. However, in our case, we were interested to know before and after, let's say, Coop's serious game, that we have actually important muscular activity, and that give us information that the virtual reality serious game is effective. That means give a possibility to the user to make a real rehabilitation. And actually, we test for different before and after the game. We make games for 4 volunteers. In this case, I present here. Actually, we make more, but for different training session. You can see here that the time duration of the session, they are not so big, because if we think about stroke patients, sometimes half minute, 30 seconds, it's a lot of time. And later, after game over, we can measure the temperature, and using Flick tools, we can estimate the temperature, the value of the medium, maximum, or even other kind of values associated with thermographic image. Here we present the results obtained for 2-minute training for different volunteers, but also regarding the score. Not always the score reflect the effectiveness of activity, muscular activity, because sometimes people with less capability to move the hand can obtain even good results. But it's not the rule, this is an exception. And in conclusion, smart physiotherapy expressed by targeted environment by virtual reality and wearable device assure increased quality of service. This was the idea, to develop new services that can be practiced in a remote way. We don't think about COVID. This project started 15 years ago, but it's very important to follow the users making physiotherapy in their home. This is very important. Also, the IoT architecture are important steps in generalization of smart physiotherapy service. Remote sensing technology, and here we speak about Kinect, lip motion, thermography, play an important role in objective evaluation, and giving an idea about physical therapy outcome for each user. Thinking about future work, actually we are already starting, we are publishing some work related the data science and machine learning based on the data that we obtain with these instruments, smart instruments. This is very important when we think to create new models to predict the evolution of different kind of training plan, and will be actually our will continue this work in the next future. Thank you very much.
Thank you, Octavian. We do have several questions in the Q&A. If you'd like to open that up.
Yes, sure. Okay, I'll start here. But first one is participant anonymous. Okay, not without name, but I will read the question. Why did you choose Arduino instead of Raspberry Pi, which is it's more performant? Okay, I can say now that actually it's true. Arduino is less performant. We speak here the work developed in the last 10 years. Raspberry Pi, we are using Raspberry Pi, but together with ESP32. ESP32 is one of the new solutions that we are using. We try to replace Arduino. And Raspberry Pi is good, but the consumption is too high. If we think about, and also the size, if we think about smart gloves that we implement with Arduino Nano, the usage of the Raspberry Pi was not proper, thinking about that we are thinking about small computation device, and Raspberry Pi is not so small, and also the consumption it's higher. We speak about more than 1 ampere hour. That means it's a big consumption. I fully agree that the capability of computation is higher in Raspberry Pi, but actually, as I say, nowadays we are working with Artemis. In the past, we are using Arduino also to use capability, higher capability with lower computation. I will write the sec. I hope that it's okay. The answer. I don't know. I can move to the next, or I will read the next question. What is better?
Yes, go ahead.
Okay. In the IoT environment with millions of active entities collecting, processing, and utilizing the captured data, what will be the role of big data and the specific analytics? What will be implication of communication bottleneck as well as security? Thank you for the question. It's very question of Dr. Zahar Takvi. Thank you for the question. You are really, it's very good, as I say, in the like future work, but actually we are starting to work in. The big data is very important. Actually, we can share data. We store data from different clinics. And thinking about the communication bottleneck, we are very optimistic thinking about 5G communication. Actually, it's right that long-range communication is like LoRa is not a solution. Actually, we are using 4G communication. That means and Wi-Fi local in order to access the internet, and after this the common internet that we have. But the future based on 5G maybe will give also opportunity to even implement more augmented and mixed reality, thinking about the lower latency. And I hope that we'll move forward with this new communication standard. Actually, we already know that appear Oculus Quest 5G compatible, that it's a platform that already we are starting to use for our implementation. And I hope that this can be solved. The data, the big data and the specific analytics, this is a very important issue. Actually, we develop our instruments, but it's not enough. We can show some data, some statistics, but the global analysis for some case, we think about stroke, how much take the different training session, how we can create good models based on this, based on big data and the data analytics applied for physiotherapy data. How do you know the accuracy of any prototype? Do you have something to compare to? Is there any special calibration for the sensors? Yes, it's true. Actually, we have, according to the system, thinking about, let's say, about gyroscope. We implement some Kalman filter, but always we need to make on the beginning of the game, especially when you are using smart gloves, we need to have a calibration phase where actually we communicate with specific phase of the game, and we can see the motion, the angle of the motion that the user is going to do, and we make the calibration of this kind. Thinking about other, let's say the force sensors was also previously calibrated. We speak about, let's say, flexible sensors. Sometimes these flexible sensors are affected in time. We need to calibrate again. We are using sometimes high accuracy load cells to calibrate this kind of sensor. Also, fiber break rating sensor was calibrated based on load cells system. Another question, again, from Dr. Zahar Takvi. For patients with peripheral disease, PAVD, and leg edema with loss of neural control of toes and feet, how will the sensing and rehab will work? Yes, it's interesting application of some of our system. We speak about smart install, but it's a big problem when we have here, we actually don't test in this, but I'm thinking about that wearable solution with smart install based on fiber optic or also classical with the pressure sensor. For the case of foot drop with neurofibers dead and not controlling foot and toes movement, how effective is infrared application as explained to you? The case of foot drop with neurofibers dead. Yeah, it's in this case, I mentioned before, the system was actually focused in some gait rehabilitation with, let's say, medium impairments where we following. If we don't control the foot or toes movements, if we think about serious game, we have also implemented serious game for foot rehabilitation of leg, and also here thinking about the smart insole will be more difficult to be effective in this kind of systems. We have also Kalin Korchova, a multitude of applications that can be easily used in rehabilitation. The question, what was the impact of using these systems on medical staff? Okay, thinking about this, actually, it depends also of the generation, of the size of clinics and so on. Actually, we're working very well with clinics, let's say small, medium clinics. We are very interested to use new technologies to have the objective values related the physical therapy training. And thinking about impact, yes, very good impact we obtain with serious gain for cerebral palsy kids that practice more, and is very important. It's a little bit difficult to communicate with some of them. For this reason, the exercise was performed together with the physiotherapist, but also the parents give their, let's say, permission, and they stay and help us to put in work our system. We have here another comments. My question is how this smart physiotherapy can help the problems of rehabilitation for countries like very high population. We speak Professor Royanta Roy from India. Thank you for question. Actually, this kind of rehabilitation imply not very high cost at the end. Because if you think about transportation cost and then remote site, if the country is very big, it's maybe better to make physiotherapy home than to travel by plane to go to physiotherapy. And for this reason, can be an opportunity, the smart physiotherapy in the next future. Also thinking now with these problems of isolation, of the population-related pandemic, the physiotherapy can be also a solution. Thinking about high population, this is another problem, because when we speak about high population, maybe this service, digital service, can permit to give service to more people than now, when you are using the physiotherapy only in the clinics. Maybe we can generalize the physical therapy in remote physical therapy. Dr. Richard Newman, have your system gone beyond prototype stage? I can say no. Actually, it's a good question. It's also a big challenge to implement this kind of, as I say, the prototype, and we test in clinics, but actually we don't have a commercial products related this implementation. Just Justin Boreanu, what will be the cost for this, and when I say that is, I mean, if everybody can afford this project, okay. As I said, the cost, usually we are using the interface, the natural user interface was expressed by devices like Kinect and so on, that it's less than 500 euro normally. And but also take a lot of time to develop the software. However, if we think that we can implement in different clinics like a service, maybe the cost will not be of this service will not be so high. I try to answer to all the questions. I don't know if other questions come. I hope that I answer to your question, and if exist other comments, please let me know.
Thank you so much for this talk, Octavian. I don't see any further questions, so I believe we can conclude here.
Okay, thank you.